Good afternoon, everybody. My name is Dmytro Zagrebelnyy, and I'm Assistant Professor of Teaching in Material Science and Engineering program at the University of California, Riverside. And I would like to present you with a little bit of an insight on MSc program at UCR today. So I will start a presentation. I hope everybody can see the presentation. So the presentation is material science, the engineering behind the modern world. In the first slide, I would like to introduce myself. So my name is Dmytro Zagrebelnyy. I'm Assistant Professor of Teaching in Material Science and Engineering program. I got my PhD in MSc from Purdue University in 2007. And after that, I went and I worked in industry. In 2009, I resolved an issue with Airbus 320, 340 landing gear. In 2011, I've been part of the team to construct approximately $100 million metallurgical facility in Canton, Ohio. In 2013, I resolved major manufacturing issue with Sikorsky Black Hawk helicopter. In 2015, I've participated in the program for industrialization of Questec M54 alloy for Navy applications. In 2016, 2018, I contributed to processing parts for multiple prototypes, Sikorsky S97 Raider, Sikorsky SB1 Defiant, Bell V280 Warlord. In 2020, I contributed to processing of wheels for NASA Mars rover, the Perseverance. And in 2021, I joined UCR as MSc teaching faculty. So I would like to say that I'm a material scientist. So let's talk a little bit who are material scientists and what do they do. Doctors heal people. Mechanical engineers typically design some machinery. Pilots fly planes. But what material scientists do? That's quite an interesting question, particularly for those who just graduated from high school, and material science as a discipline typically is introduced only at the university level. So let's start from the very simple questions. Things around us, simple things like a paperclip, maybe a chair, or maybe a phone, or maybe a jet fighter plane, or industrial scale excavator. All these things are made of something, and that's something that's materials. And if we look around ourselves, it will be very challenging to find something which is not made out of materials. So materials are an important part of our life. Some materials occur fairly naturally, like trees. Trees just grow, and out of trees we make lumber, and out of lumber we make things. That's pretty simple. However, other materials are invented and synthesized by people like you and me, by material scientists. And in this case, we are seeing the manufacturing of carbon fibers, and out of carbon fibers, we make carbon fiber composites, and carbon fiber composites used for more advanced applications, such as sport cars. Some materials can withstand extreme temperatures. If you look inside a jet engine of a fast airplane, you can see a glowing, not even red hot, but orange hot temperatures. And some materials have to operate in those temperatures for a long time. Modern jet planes are fairly reliable and fly from one continent to another. And I flew recently to Europe. It's a 12-hour flight, and those engines with red hot temperatures operated quite well. Other materials show great strength. For example, in tall buildings, which have very high weight, and they operate also in quite difficult conditions. Sometimes there are strong winds, sometimes there are earthquakes, but they still stand. And they need very strong materials to withstand all that weight of that building. So there are some quite special materials which support those buildings. Overall, a human society is breaking new barriers every day. We are sending automatic robots to different planets with quite hostile conditions relatively to where we live. And those apparatus operates for quite a bit of time in those conditions. These days, probably most of the people carry smartphone, and smartphones have more computational power than older computers which navigated the mission to the moon. Yet it's a common thing now, but it wasn't common 30, 40 years ago. They need some special materials to operate that way. Again, these days we see electric vehicles on our streets every day, and they have some quite special materials to enable those electric vehicle to enable the manufacturing of those vehicles. It's a daily routine now, but it wasn't quite a few years ago. And as humanity evolves, it needs new materials which allow us to push the barriers further. It needs understanding of new materials and how they behave. It needs understanding how those materials processed, manufactured, and made into the what we call common things these days. So to give a little bit of a quick summary what material science is, we'll start with simple. The performance. The performance, that's what drives the material science. The humanity needs to fly farther, faster, create new sources of energy, create smarter devices, and we call it all performance. And a lot of the performance is based not just on simple engineering, but on the materials behind that engineering. And the performance is achieved through material properties. We have materials that can withstand higher temperatures. We have materials which are stronger. We have materials which are smart materials, and they behave in a certain way because of their structure, right? So properties come from the structure of the materials, and structure is very important. We can have composites of layers of different materials. We can have different internal arrangements of atoms. In this case, we can have a nanotube. We can have different grain structure of the material or arrangement of the material internally, different, which will drive the properties, which will drive the performance. In order to obtain particular structures of the materials, we process them. We process them differently. And processing techniques, that's what enable us to produce new human developed materials. And the processing that allows us to change the structure, and through changing the structure, allows us to change the properties of the materials. And that enables the performance of human society and what we achieve ultimately. So altogether, these essentially outline what material science is and what material scientists do. Except there is one more area, the characterization. So material scientists specifically trying to look into the materials and understand their structure. Try to look how the atoms are arranged, why they're arranged in certain ways, and you can use microscope or you can use more advanced techniques. And currently there are quite a few advanced techniques up to the point that you can actually see individual atoms in the materials and how they're arranged. And that's area of characterization, which is also very important for material scientists. So altogether, that's what composes the material science and engineering in the modern world. Now, if we look at UCR, UCR, Bourne's College of Engineering, so that's specifically part of UCR, which is responsible for engineering part of the college, engineering disciplines. It has pretty good rankings. It takes top 50 in US public research engineering colleges, number 3 in Hispanic STEM graduates in the nation, number 28 computer science institution. It it made it into top 40 in best engineering schools by salary potential, number 6 in public universities making an impact, and number 5 stars in quality education and affordability and outcomes. So these are pretty good rankings for a university. Material Science and Engineering program is part of Bourne's College of Engineering at UCR. And our mission at MSc is to prepare students for professional practice, graduate study, lifelong learning, and to advance the scientific and technological basis for material science and engineering practice. So we consider both aspects. If you planning to go to industry after graduation, or if you continue studying in graduate school, we try to give you skills and mind to continue learning and continue progressing even after you graduate. And we aim to provide fundamental knowledge for understanding of materials with the objective of predicting, modifying, and tailoring the properties of materials to achieve enhanced performance of the materials and devices based on these materials. UCR MSc research areas, specifically what we focused here at UCR in terms of our program, that's biomaterials. Biomaterials is a very wide field, and a lot of people need help in terms of various materials that help to improve human life, including implants, including teeth fillings, including various fixtures. It's also a lot of medical applications involve materials. Then structural materials, the materials that used for various structures and make essentially that's what our world is built of. Computational materials. So computational material science is more of a predictive material science when you try to predict the behavior of materials or simulate behavior of materials based on the computer simulations rather than doing the experiments. And sometimes experiments simply not possible. That's where computational material science comes handy. Then materials processing. Most of the things that used around us, it's not just materials. It's materials made in particular shape, made in particular properties, combined in different combinations. So that's all big part of material processing, and there is a huge demand for material scientists in material processing. We also have the areas of electronic, optical, and magnetic materials. Electronic materials is a big area because semiconductor industry is still burgeoning. The computers needed to be faster and faster. Smartphones needs to be smarter and smarter. And so is energy application when the society is trying to transition to more environmentally friendly generation of electrical power. That requires quite a bit of special materials as well. One of the common applications that I've dealt recently is upgrading our power grid. We're all talking about electrical cars these days, right? But then in California, when it gets very hot in summer, They say, please don't charge your Tesla because everybody running AC and our power grid is getting overloaded. So there are new materials to upgrade our power grid. And it's also the job of material scientists. In terms of UCR MSc curriculum, so UCR MSc curriculum is based essentially on the facets of material science and engineering. First of all, we look at the fundamental knowledge essential for understanding the concepts behind MSc. Typically, the school program doesn't provide enough chemistry, physics, math knowledge to directly study MSc subjects. So first couple of years, the focus is to gain more the fundamental knowledge. And that's what probably you'll use as an engineer for the rest of your life. Then we have courses focused on characterization of materials, specifically learning various characterization techniques and what we can learn about the materials and how we can look inside the materials and understand their behavior. Then we have courses focused on processing of materials, specifically how materials can be processed, manufactured, and combined into the common objects that we use every day. We have courses focused on behavior and properties of the materials, so how we test the materials, how we measure their strength or other characteristics. Our curriculum is a good combination between theoretical understanding and theoretical courses, as well as hands-on experience. And finally, the curriculum has the flexibility to fine-tune your end expertise with technical elective courses. So not all the courses are mandatory courses. There's about 5 courses that you can pick out of different areas, whether maybe you have more interest in electronic materials, maybe you have more interest in biomedical applications, or structural materials, or metallurgy. So the curriculum gives you enough flexibility to choose and pick some of the courses. So when you graduate and leave UCR, you have more expertise in a particular area which you're more interested in. At the end of the 4th year, all our students are involved in senior design. And senior design, it's a two quarters course, which is essentially present a challenge to apply what you've learned at UCR towards real material science problems. Typically, our projects in senior design involve either local companies or faculty research, and you essentially having pretty good time applying your knowledge and solving actual problems, and then presenting them at the end in senior design showcase when faculty and families and friends can come and you can shine and show what you've done, what you've learned. And these projects usually serve as a very good purpose towards the interviews when you're applying for jobs. You can actually share how independently you worked on MSc project and what you've achieved. Quite a few of our students got jobs based on their senior design experience. So what UCR MSc graduates, where do they go after they graduate? This is the list of companies that I've personally known our graduates got jobs with in the past few years. And as you can see, there are quite a few well-known names, such as ATI Forgings. It's a large USA-based company producing aerospace parts. General Atomics, they make military drones. Collins Aerospace makes the composite parts for the large commercial and civil airplanes like Boeing 787, Boeing 757, and so on. Northrop Grumman. Northrop Grumman is a large military contractor in the United States, Pratt & Whitney makes the jet engines. That's where the heat and the power goes. A lot of Pratt & Whitney engines go into military aircraft. However, they also power the civil aircrafts, including Boeing 757, for example. Naturally, Intel or HLR laboratories, that's the semiconductor field, and one of our graduates this year, he went to Intel as a process engineer. So there is a demand for semiconductor engineers with material science and engineering background. TSMC, the Taiwan Semiconductor Manufacturing Company, probably the most advanced company in the world in semiconductors. They're currently building a facility in Arizona, and they are very interested in our graduates. One of our students went with Virgin Galactic, so he is a materials and process engineer for Virgin Galactic. He's been there for a couple of years. TS Conductor, that's the company that upgrades our power lines. The students did the projects with them, and after the project has been completed, they hired a couple of students out of the team straight through. They graduated and they transitioned into the company right away. There is a number of metallurgical companies such as Superior Handforge, Howmet Aerospace, which hired our graduates straight out of UCR, essentially. So these are the typical companies where our graduates go. Typical entry roles for UCR MSc graduates are processing engineer, metallurgist, quality engineer, materials and process engineer, metrology engineer. I was surprised, but even Microsoft hired one of our graduates because they needed MSc engineer. So you can learn more about material science and engineering program from our website. And if you join MSc, that's when you can enable the future of human society. Thank you. That's all I have in terms of presentation. Is there any questions for me?
Okay, here's a question. Are there any scholarships specifically for UC engineering program that I can begin applying to before acceptance decisions comes in?
I believe there are scholarships available for students. Personally, I'm not familiar with the scholarships part.
Let me see if I can find a link and pop it in the chat. The next question is from, I think it's AO, asking, do you know the average salary for an engineer?
The average salary for MSc bachelor degree graduate is approximately 70 to 80,000 a year. I have actually the data. We looked at it, and actually MSc engineers at the entry salary make more than most of the other engineers.
Professor, there's another question. Do material engineers work in nuclear energy?
Yes, material science and engineers work in nuclear energy. Well, material science and engineers work in every field because, again, every field uses the material science, some type of materials, so they need the people who understand the materials, right? There are specific fields which are nuclear engineers, which are familiar with material science, but first of all, there are directly material scientists who are involved with nuclear energy because materials under conditions of nuclear applications, they tend to degrade. So there are people who specifically study the degradation of materials in nuclear applications. And then there are material scientists who also manufacture the materials for nuclear energy and nuclear weapons applications. It's not very wide field, but yes, there is a certain amount of material scientists working there.
Professor, I'm going to send you a link before I post it about the salary so that you could verify it. I'm going to just send it directly to you.
All right, can you see my screen?
Yes.
So this is the comparison of salaries for the mean entry. So entry position, that's the first column. Then the mean annual, that's the typical salary in the field. And top 10%, that's the more towards who make the most money. But you can see at the entry level, material science and engineering, that's this third line from the top, their range is higher than most of other other engineering disciplines in the college, actually. So between 79 to almost 100K a year. And that's for we're talking about the bachelor's degree. So that's pretty good.
Okay, well, if there are no additional questions, then we're going to go ahead and end the webinar now. And thank you very much for joining us. We appreciate it. Please connect with the admissions department if you have any additional questions regarding your application.